Hello, 8th graders. Today's joke of the day is, what type of tree likes to give high fives? Stay tuned to find out. Our learning target for today is I can graph 3 ordered pairs and find the hypotenuse of the right triangle. Okay, so in order to do this, we might need to use the Pythagorean theorem or the distance formula. Okay, I'll show you how you can use both. So let's remember that the Pythagorean theorem is a squared, I gotta grab the pen here, a squared plus b squared is equal to c squared, where we have a right triangle, and a and b are the legs of the right triangle, and c is the hypotenuse. Okay? And the distance formula is d, which is going to be the length of the hypotenuse, is the square root of x2 minus x1 squared plus y2 minus y1 squared. So it's the difference between the x coordinates of the 2 points, square it, plus the difference of the y coordinates of the 2 points, and that squared, and then you take the square root of all of that, which comes from the Pythagorean theorem. We can use either of these to find the hypotenuse of a right triangle on a graph. So we are going to look at this example here. We're going to graph the points and then find the hypotenuse of the right triangle that is created by the points that we graph. So our first point is -3, -1. So put a point there. +2, -1, and +2, +3. Okay, so we made this right triangle, and we are going to look for this value here. Okay, that's our unknown. So let's first look at how we can use the Pythagorean theorem. Okay, we can use the Pythagorean theorem here because we can count how many points, or how long each side is, right? So this bottom side here is 1, 2, 3, 4, 5. Okay, that's 5. So you want to count like the full boxes or the full spaces that it travels. And then this one here we have 1, 2, 3, 4. Okay, so both of our legs are 5 and 4. So we can use the Pythagorean theorem by saying that 5 squared plus 4 squared is going to be equal to c squared, okay, or that distance that we don't know squared, okay? So we will do this then. 5 squared is 25 plus 4 squared, which is 16, is equal to c squared, okay? And we end up with 25 plus 16, which gives me 41, is equal to c squared. And then we take the square root of both of those. So c is approximately going to be equal to the square root of 41, which, let me get my calculator out here. The square root of 41 is 6.4. We'll just round to the nearest tenth. Okay, so our distance there is equal to 6.4. So that's using the Pythagorean theorem to find the hypotenuse of a right triangle once we have graphed all of the points. Okay, for this next example, let's graph the points, and then we will use the distance formula. Okay, so first we start with the point 1, 1, and then we have 5, 1, and 1, 1, 5. Okay, so we'll draw our triangle in here. Okay, this is the length that we don't know, the one that we're looking for. And let's use the distance formula. So these are the points. Let's see. This is 1, 5, and this is 5, 1. Okay, so really we're just finding the distance between those 2 points, and we can use the distance formula to do so. So we'll say d is equal to the square root of, we have to subtract the x values. So I'll take x2, I'll say this is x2, 5, minus x1, which is going to be 1, and then square that, plus y2, which is 1, minus y1, which is 5, and we'll square that. Okay, so so d will be equal to the square root of 5 minus 1 is 4 squared, plus 1 minus -5 is -4 squared. Okay, and then we have d is equal to, well, 4 squared is 16, plus negative 4 squared is not negative 16, but a positive 16, because a negative times a negative always gives us a positive number. So then D is equal to the square root of 32. We'll add those together, and we can find that the square root of 32 is equal to 5.7 if we round. So D is approximate. Let's write that as approximately equal to 5.7. And that will be the length of our hypotenuse of our right triangle there. Okay, so that's using the distance formula. All right, let's look at one more example. And now for this one, we could choose to do whichever one that we wanted. I'm going to do another example where we just use the Pythagorean theorem. Again, you can always use whichever formula works best for you and which one makes the most sense for you. Both will give you the same answer. Okay, so in this case, we have -2, -4 is our first point. We have -2, +4. And we have +4, +4. Okay, so our right triangle is kind of upside down here. Okay, and we can figure out the lengths of our legs. Let's see, this is 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8. Okay, 6 and 8, and then we don't know this side over here. So let's then use the Pythagorean theorem. We'll take 6 squared plus 8 squared is equal to c squared. That will mean we have 36 plus 64 is equal to c squared. 100 is equal to c squared. We'll take the square root of both sides to find out that c is equal to 10. And it's exactly equal to 10. And that is because 6, 8, and 10 form a Pythagorean triple, right? So if you knew that right away, you could look at 6 and 8 and say, oh, this is a Pythagorean triple. We know that the length of the hypotenuse is going to be equal to 10. Okay, so with finding the length of a hypotenuse from a graph, you can either use the distance formula or you can use the Pythagorean theorem, whichever makes the most sense to you. All right, then for today's joke of the day, what type of tree likes to give high fives? A palm tree. Thanks for watching and have a great day.